Gliding, flying with no engine. How far can you glide? So what's gliding about? Gliders are aeroplanes that have no engine, so they rely on pilot skill and rising air to keep them flying. They can go high, they can go fast, and they can go a long way. They need a bit of a hand to get airborne, and the usual ways of getting into the air are either a winch launch, where you are pulled, like in the picture on the left, with a cable, and as long as you've got enough speed you can climb, or towed up behind a power plane. That's called an aerotow. Once we're in the air, we use thermals to climb. So a thermal, or lift, it's a bubble of warm air rising off a hot place. And between thermals, the glider just loses height continuously, but then when it gets into a thermal, it can circle or do anything like you can see here to stay in the rising air and to climb. Now, once you've climbed, you can glide on your way, but different gliders use different amounts of height to fly the same distance, and this is called their glide ratio. So today we're going to look at how you can calculate the glide ratio. And this is how we fly cross-country in a glider. We glide, we find some thermal, and they're often marked by little puffy clouds, the summer cumulus clouds that you see, and we can circle to stay in that column of rising air. We can climb, we can glide out to the next one, climb, glide, until we get to where we wanted to go, or back to where we started from. So to calculate the glide ratio, as you can see, the glider is climbing in the thermal and then gliding on its way. So glide ratio is the distance you go over the height you lose doing it. The distance you go over the height that you lose. And what we're going to do today is have a look at how to calculate that. But first, let me show you the sort of glide ratio you get with different aeroplanes, because it's not just gliders that will glide. All aeroplanes will glide, it's just gliders do it better. Let's have a look at the typical light plane you might see flying around. Here's a Cessna. As you can see, that'll go 900 metres from 100 metres up, so it's got a glide ratio of 9 to 1, whereas a Boeing 747, a jumbo jet, will do 1700 metres with a glide ratio of 17 to 1. But if you really want to glide, you need a glider. Here's a Nimbus 4, and that'll go 6 kilometres from 100 metres up, so a glide ratio of 60 to 1. Now that's useful for getting you around the country. Okay, here's a picture of my glider, which as you can see is called 0. That's its call sign. So your challenge, if you choose to accept it, build yourself a glider and calculate its glide ratio. There are instructions on how to build it in your worksheet, and make sure between everyone you make all of the designs so that you can test which one works best. And once you've done that, you need to name it. Now, glider's name is normally 2 or 3 letters, as you saw. It's written on the tail. It might be 620, it might be Hotel Alpha X-ray. So decide what yours is going to be, and when you've made it, write it on the tail. Once you've made it, you're going to measure the glide ratio, and then you're going to do some exercises. So the first question is, how far will your glider fly if it starts 10 metres high? Question 2, how far would it fly from the top of a tree? And we've told you how high that tree is. Question 3 is how far it would fly from the top of the Eiffel Tower. Now, 384 metres. Did you know it was that high, the Eiffel Tower? Question 4, thinking caps properly on here. How high does your glider need to start to fly the length of 5 cars? And the cars are 4 metres each long. In question 5, though, we've got some different cars. So what's the minimum height you could start to fly over your choice of 5 cars? 3 of them are 4 metres long and 3 are 3.5 metres long. And then the last one, question 6, what height would a Nimbus 4, which has a glide ratio of 60 to 1, need to fly over 5 cars that were 4 metres long? It's probably got a better glide angle than yours, but we'll see, won't we? and I thought you might like to see how I did it when I had a go. So here's a quick bit of video showing you that. Okay, so we've got a number of different glider sorts here. I've got two foam ones, a big one that looks like a glider, got a unicorn here, and we've got the three designs that you're going to be making this morning. And you can try any others you might happen to have with you. Here's the simplest one. Here's the one that looks a bit like a dart. And here is just a bit of a stunt plane, really. So let's have a look and see what glide ratio they all have. Let's start with the orange one. We're going to launch them all from our launch point here. And what we're going to do is just stretch this rubber band back to, we've got a little point here, marker, and we're going to launch them all by stretching the rubber band the same amount. So here we are, that's now stretched. Oh, that went 1.3 metres. Let's try the little unicorn. Definitely likes going off to the left, doesn't it? Okay, so now let's have a look at the three that you've been designing this morning. I'm going to start with the very simple one, and I've got it folded so that the wings are sticking up a little bit, and we've got the paper clip to put a bit of weight on the front. And again, this one doesn't have a hook, so we're going to launch it by stretching the rubber band from the back. Oh, very simple, but quite effective, look. That's gone 3.7 metres. Now I'm going to have a go with this little one here. Put it on the board, stretch it out. What do you reckon? Long way, short way? We'll find out. Whee! But it only went 1.7 metres. And then the last one here, the sort of fairly standard paper dart. Stretch the normal amount. That wasn't very good, was it? What do we got? 1.2. Okay, so we know how far they've gone, and we measured this before we started. How high was it? That's right, it was 300 millimetres high. So we can work out the ratio between how high and how far. And here's Hotel Zulu landing, so it's over to you to make your glider, measure the glide ratio, write all your results up in a nice table, and then get on with the exercises. Good luck, have fun, and we'll see you when you're done. Have you discussed your results with your teacher? We hope you've had fun today, making gliders, learning a little bit about gliding, doing some calculations around glide ratio. And now that you know how to calculate glide ratio, maybe you want to find out a little bit more. You can find out about gliding and all types of aviation at those links there. You can meet inspiring people on the website, and just think, you could be doing this perhaps in your career. Have a look at the STEM CAA site. All of those links are in your student notebook, and we really hope to see you on an airfield soon. Bye for now.